Good afternoon, Year 10. This is the video for your whole class feedback based on the last couple of weeks' work. First of all, we'll identify a few common issues. First of all, a plea from me: when you're editing a booklet like the mastery booklets that we're using, try to make your answers stand out from the questions. If you don't do that, it's very difficult for me to actually extract your answers, to find your answers in amongst the work. Secondly, a little bit of formatting. We can say meters per second instead of meters per second squared. They're equivalent ideas, but we don't tend to use meters per second when we're writing down the units for acceleration. I get the feeling that we did this because it's much easier just to press /s than to do a superscript 2, but I've got a little tip here for you. If you press Control, Shift and plus, then the next word you type will be in superscript. So it makes it really, really simple to put in that seconds squared part. And then finally, quite common error. People were very, very good at recognizing that acceleration is a vector, so you can have acceleration when velocity is changing because the speed is changing or because the direction of the velocity is changing. But sometimes people missed out that actually both can be changing. So when you bounce a ball, it is accelerating towards the ground initially, so it is increasing in speed as gravity pulls it towards the center of Earth, and then also when it hits the ground, its speed is reducing and its direction is changing. And then its speed is increasing and its direction is upwards. So remember, both can change. Okay, for dirt activities. If you haven't completed all of the work from the last 2 weeks, I feel like there's some really basic ideas that we have to be able to do. So I'd like you to research and then sketch a distance time and velocity time graph of an object in these 3 different situations: moving at constant speed, accelerating, and stationary. So that's 6 graphs in total. And try to lay it out so that you can see the similarities and differences between the dt and vt graph for the 3 different objects. Assuming you have done all of the work from the last 2 weeks, then I'm going to give you an extra developing task that asks us to plot a specific dt and vt graph, and also to annotate it, to describe what's happening in different sections of this graph. I'll do a separate video on that that'll be going up shortly after this one. The stretch task is actually much more difficult than it seems. It seems a lot like the consolidate task, but actually it's significantly tougher. I'd like to sketch graphs for a Formula 1 car being driven by some rubbish driver like myself around a circuit. I don't mind what circuit. I said Silverstone because it's the UK Formula 1 track, but show me how distance changes with time, how displacement changes with time, how speed changes with time, how velocity changes with time, and how acceleration changes with time. Then I'd like you to repeat that, but with an actual competent driver at the wheel. What would be different? Some of the changes will be obvious, but some may not be. Please do that if you find the developed task straightforward.